I don't know what's wrong with it. Let's start it, man. Man, what the heck? Live? Okay, I think I'm live. So today, first of all, um, so hi, welcome to High Entropy. It's day 58 of DSA learning, starting little late or very late. And I don't know what is happening with my camera. Actually, it's flickering. Here I don't see flicker, but here I'm seeing. So if you are seeing, so sorry for it. You can see like in the background, but that is not important. At least you can hear my voice properly. So today's agenda is simple. Yesterday I was trying to solve a problem, and that problem I wasn't able to solve. And then I thought, okay, let's drop the idea of solving that problem. And I was not getting my uh, mistake. What was the mistake that I was making? So I was trying, and the reason was simple. Like I was trying to get the values from starting to that particular time point, and then I was deciding. So that was the wrong. So okay. So after that, what I thought, okay, it's not working. Then I up changed the approach, and I was for GPT and all. Then also I was not getting. Then after analyzing it so many times, then I was able to grasp it using the recursion and memoization technique. But then after that I thought, okay, memoization is working. Let me jump to tabular format. So I tried to convert the code into the tabulation method, but it worked for the sample test cases. And after that, I started feeling I'm getting bigger number, so I have to debug that. So for the time being, I'm parking that problem at least because I'm able to solve one part of it. Tabulation method I will try tomorrow, but right now, what is the approach? What is the agenda? It's simple. I'm gonna solve the next problem because we have to move forward as well, so that our morale should be high. Yeah, if I haven't solved it even with one approach, then I have to wait it. So I won't keep it like a solved until I'll solve the tabular method. Let's jump to the target sum. I think it's if it is the same problem or it's target sum with the unbounded knapsack, then we'll get to know. It's a different problem. So let's see. So what is the today's goal? So let's take a time clock. Let's target 1 hour to finish this problem. With any one approach, our morale should be high. Okay, you can see the time here. And second thing is we have to learn it. We have to grasp the concept. It could be irrespective of this whether we are able to solve it using tabulation or memoization. If you know, what I got to know from the Adit Verma's videos, and also based on my observation, always it is whenever you are approaching a dynamic programming problem or DP problem, then the parent of it is recursion. So if you are able to solve it in recursion, then only jump into the, if you are able to visualize the recursion, then only jump into the tabular method. If you are not getting, then you might be trapped or you won't be able to come up with solution. So that's what. But I always make mistakes, and sometimes, so today's talk, what is the agenda of our day? I mean, for next 1 hour, simple. We have to. I have to keep myself calm. First thing, very important. Always like we used to. Okay, we used to create blunders, and we used to make blunders while attempting the problems. Especially if I'm talking about my personal experiences, I always used to blunder, and especially when there are so many. There is time foundation, then I feel pressure and I start panicking, and I make more mistakes, and there are chances like I will jump between problems. Like for example, if there are three problems, then I might jump into first, and I will try for the next 15 minutes. If it's not working, then I'll jump to another. I will try for 15 minutes. If it's not working, then I will jump to third problem, and I will see, okay, it's working or not. I will be able to solve, or will I be able to solve or not? And that way, like I will make porries of all the problems, and finally it would be even hard for me to solve one problem. It always happens with me. So it's better stick to one problem. Don't jump here and there. focus on one. If you are like, okay, I can't solve it anymore, or I won't be able to solve, then jump into another problem. Maybe you have to sneak peek first which problem is approachable and solve that, so that you don't waste time at starting and you can approach the problems that are approachable. Okay, so it's easy to give the guidance, but it's easy to follow them. Okay, so let's jump into the problem and read it first, and then we will try to conclude the solution if we can get it, and we'll try to like a what we say formulate the solution, and after that we'll jump into the coding. So first part is we have to grasp the problem. Second part is we have to write down on paper. So here I'm using digital paper. Third step is write down the code, and also in the coding part I make a lot of mistakes, and sometimes typo error, sometimes not checking the properly the boundary condition and all, do even writing it here on paper. Okay, so let's target 45 minutes I believe. And so first 10 minutes or 20 minutes, so I will start a timer. I don't know if it is available here. I think it's available here. Keep timer, and let's give it 30 minutes. So I'm targeting 30 minutes for solution. Given an array nums of n integers. Okay, given an array nums of n integers, add an integer target. Okay, great. Build an expression using the integers from nums. Okay, build an expression using the integers from nums where each integers can be prefixed with either a plus or minus sign. Okay, the goal is to achieve a target sum by evaluating all possible combination of these signs. Okay, goal is to achieve the target sum by evaluating all possible combination of these signs. Okay, so first thing I got to know. Given an array of n integers and n integer, build an expression using the integers from nums where each integer can be prefixed with plus or minus sign. The goal is to achieve the target sum by evaluating all possible combination of these signs. Okay, so thing is, we have to consider all the numbers, right? Okay, and let's don't forget to read the last line. That is also very important. Actually, most important. It is asking determine the number of ways to achieve the target sum and return total. Return your answer with modulo 10 to the power 9 plus 7. And if you remember, like in past videos, I made a blunder where I was using 10 is to power 9, and it should be 1e9 plus 7, or you can use 10 to the power 10 to exponent module like exponent save 9 plus 7. So what I'm thinking, I always have two options with a number. First is plus minus, second also plus minus, and so on. Okay, so every number should be part of it, right? Okay, we have given number 1, 2. Once more I wanted to read it. Might I miss something? Given an integer array of num n. Okay, what is time? 3 minutes I wasted. Not wasted, I am grabbing the information. So given an array nums of n integers and n integer target, okay, everything looking smooth, and build an expression using the integers from nums. Build an expression using the integers from nums where each integer can be prefixed with a plus or minus sign. The goal is to achieve the target sum by evaluating all possible combination of these. Determine the number of ways to achieve the target sum and return your answer with modulo 10 to the power 7. I'm just worried, or I'm just thinking, can it be Okay, I'm just thinking like, okay, is it they haven't build an expression using integers from nums, where each integer can be prefixed with. Okay, they haven't mentioned, that means we need to consider all the elements, and based on examples also it's like, otherwise what you can do if you don't have to calculate, okay, then there are so many examples, like you can take 1 plus 1 plus 2 plus 1, then it will be 4 5 4, right? So that is not the part of example, so definitely we need to consider all the elements first thing. Now let me note down the example. First let me zoom it to 100%. 1275715. We have 1, we have 2, 1, we have 7, we have 1, we have 5, and each item has two options, either consider it plus or minus. Then another you can say like plus or minus, and so sorry, plus minus and plus minus, plus minus. Okay, looks good, but how you will decide it? So our target is 4. Okay, right, target is 4. Now you can say, okay, no problem. What you say? I want target 4. Right now I'm at the first location and I got the number. Okay, number has value something like 1. So I have two options, either take plus or minus. There are two options only. Okay, so if we'll take plus, then target will become target equals to target minus 1. If you are taking plus, okay, here you are performing opposite operation, because you took plus 1, that means you need plus 3 more. Okay, so target. If you are taking minus, then you will say, okay, no problem. Now I need, okay, minus 1 I have, 4 I wanted to achieve, that means target equals to target minus, and you can say it's like you have to add it. Okay, now you need 5, right? So you should take. Now you will say, okay, I'm able to get this. Now just tell me what you want to, what you will be able to get. Okay, you will say, okay, no problem. Now I will ask further, and I will ask further. You are at the second example, and you will say, okay, so you are at I equals to 0, you are at I equals to level 1. I mean, here you are at I equals to 1, I equals to 1. So you will say, okay, no problem. There are 4 options. Here you will see, okay, now sometimes this will repeat, maybe same target with different I. Okay, so one thing for sure, you are at I equals to 0. Now you are at I equals to 1. And what is your target? You are looking for some target, right? So can I say we need a dictionary, or we need an array to memorize I and target, remain the target value that we are looking for? Okay, good, you will say, okay, we'll memorize it, but what will be the condition when we are at the base condition? Let's see the base condition. When you have one element, right, now you will take plus 1 or minus 1. No, so sorry, you will take plus or minus. Okay, before it, can you decide whether we will be able to solve it? No, you have to go through all the elements. So That's why you have to go through all the elements, then only you will be able to decide whether it is possible or not possible. So that is one thing, condition for sure. We need to explore. It's not like whenever you are getting stuck at some, just return, okay, it's possible. From another branch, it's possible. From another branch, possible. No, you have to explore all the elements. So definitely I will be n minus 1. Till there we have to go. Now you'll say, okay, no problem, I will be n minus 1. And now you'll say, okay, when you are at the last element, so you have to click or not take. So you'll say, okay, what I'll do, target will be plus area of I minus 1 and target minus area of I minus 1, and if any one of them is 0, if equals to 0, what I require, you can say result if equals to 0, return. Okay, this is one possible option. If not possible, then simply return, okay, this is not possible, so you will return 0. From here you are not getting something, from here you are getting something. Will there be any other conditions? No. If it is not 0, then that means you cannot expand it further. I mean, yeah, it could be negative target, could be positive target, and if you are somewhere in between, like you are getting the result, and then it is well and good, otherwise you can't. I hope I covered all the options as usual, and I don't think there is any scope of mistake. Let's see, define. Okay, let's do one thing first. What about, okay, so let me wrote down the exam. So, right, solution. We'll create one function. Was I sharing the screen or not? I think I was not sharing. I'm sorry if I was not sharing. Function I target, okay, and then what was else, array and n, let's say, and let's take memory as well. So first thing, not square bracket, if let's take I equals to n minus 1, then there are two options. Let's take plus equals to target minus, when you are taking plus sign symbol, that means target is gonna reduce because you considered the positive value. Target minus area of I minus 1. Not here you are taking from I, so I only, minus equals to target plus area of I. Minus means you reduce the number, definitely then target will be higher. It's like you have some value and you added weight negative, so it will increase, right? So for earlier your target was 5, now you added minus 2 to it. I mean, you added a minus 2 number in the value. That means now you need to find, if you wanted to achieve 0 target, that means you have to use 5 plus 2, 7, then only 7, then only it will be counter and you will get 5 target. Got it? Okay. If plus or plus equals to 0, okay, just forget it. And yeah, can it be like both of them are 0? Not at all, right? Return 1, else return 0. Otherwise, what are the cases? If mem of I and target greater than equals to 0, return mem of I and target. And else you will take you will consider two what plus goes to, you will say okay, no problem. You will say function, and here you will say I plus 1. You are moving to next element, and plus means you are going to minus the value. You took plus 1, so target minus area of I minus 1, and keep all the element minus 1 I plus 1 target plus area of I minus 1, so on, both, and return. So result will be like whatever the options, either you are getting this or this, maybe you are getting somewhere else, and plus minus, and I happen, and so result will be plus minus. Sounds odd, right? And finally memory I, and what is target, whatever target we have right now, equals to result, return result. Okay, first let's solve it using this. If it is clear, then we will jump into another solution. So 14 minutes 29. So let's say 24, I took 14 minutes to do that, and I equals to, let's not I, we have n, we have target, we have nums, and return. Let's create memory first. Memory will be something like for, it will be I into say number of elements. So for what we'll say like a minus 1, let's take, okay, let me just see the constraints. I haven't checked constraints. So number of the value of an element can be up to 1000. It could be 0. So okay, target could be negative as well. Very interesting. Target could be negative. So we are checking everywhere, like target is negative. What does it mean? I wanted minus 1000. So every time you are either adding number, minus 1000 means you are negative number you are adding. It doesn't matter whether you are taking positive or negative. If you are able to get the 0 at the end, that means okay, right? So let's say your target is minus 5 and you have 2 and 3, or let's say 4 and 1, not 2 and 3, let's say, and your target is minus 2 minus 3. So what you'll do, you will do, when it is minus 5, if you are taking minus 2, if you are taking negative number, that means you are adding 2, and you are taking plus 2, then it will become 0, and that is one possible option. Yeah, so this is one thing. And just I'm thinking like n can be 1 to 100. That means there are a number of elements, and nums of I can be 0 as well. So if it is 0, what does it mean? Will it I'm just thinking. Okay, so we don't need any possible combination. Definitely 0 will be also the one condition only. If we are okay, let's take example. So we are not checking at any place. So you will say like, okay, 0 I'm taking, so you will say plus 0, and finally you will say minus 0, we'll say plus 0 minus 0 plus 0 minus 0. I mean, there are options, right? So it should return all the options. So okay, if they are not expecting only one, for -1 in range, okay, underscore in range. So what are the different conditions? Like here you need target +1, and for underscore in range, what you are looking for? 1 to n. So if you are at the n, I mean 1 to range n, 0, we are looking for 1, 2, 3 and -1. And for, let's say, return result self dot solve, and here we'll pass 0, 0 is I, and then you are gonna pass target n nums and memory. So then define I don't know what's happening with define solve self, and here you will pass I, that is index where you are, which element you are processing, and then target value. A target will be what target, and n number of elements nums memory. If you will say I equals to n minus 1, then you need to check plus will be nothing but oh, so nums of I, if you're taking plus, that means you need to subtract it, target minus nums of I, and minus is equals to target minus plus nums of I. Okay, it's opposite, it looks in, that's if plus equals to 0 or minus equals to 0, return 1, else return 0. Okay, so this is the condition. And finally, if now we need to check if mem of I and target only is greater than equals to 0, return mem of I and target. Okay, if it is not, then plus, we will say plus. Okay, I'm taking plus value for the current element, so target will become self dot solve, and you will say I plus 1 for move to a next element and decide target minus array of did I keep it anywhere, array nums of I comma n and nums and memory minus equals to self dot solve I plus 1 I target minus, instead of that nums of I, you will take plus n nums memory, memory, and we got plus minus. And finally what you will do, either you are getting from this or this, return plus minus. No, before returning, don't be in hurry or don't be in rush, solve it. I hope, I'm thinking like sometimes I hope but it not works. So let's say result equals to plus minus, and if you forget, I forgot one thing. You know what? You don't know. Mod is equals to 1 e, no, let's take, because I have to take plus 7, so plus minus, and you will say okay, we are getting modulo every time, so only we need to take modulo percentage mod, and you have to do mem of I and target is equals to result, return result. Great. So do you have made like what is my feeling before solving it? Okay, then I will if I will say something wrong, I haven't able to solve it, then I will say, okay, I was thinking like this, but it hasn't worked. So right now, what I'm thinking, everything I kept correct, and let's see and see this solution. And I believe I haven't made any mistake, but oh man, first mistake. Mema phi and target. What the heck? Where I made mistake? Now I will choke. Definitely. And I am using something not good. Keeping my legs folded all the time. So I'm seeing joint pain. I'm getting older day by day. Well, everyone is getting older by. I equals to n minus 1 plus added this minus this added this blah blah. For underscore in range, I'm in 0 to n minus 1. But where comes the problem? I will start from 0. I will jump to I plus 1. Okay. I will jump to I plus 1. Print I. Where is the problem? Out of range, so it is not here. It is more about here. Oh god. I'm off. I return result memo of I target. If I'm keeping target. Wait a minute. Oh, okay. I got one thing. Target can be positive, target can be negative. So the challenge is I got it. And it could go up to all the numbers in negative direction and all the numbers in positive direction. numbers are positive only, but this value can go up to, I mean, all the numbers. Okay. Okay, one thing for sure. Here they are mentioning like it can be sum of area of I. All the elements can go up to 10 to the power 4, so it means 10 to the power 4, 10 to the power 4, double of that number. So is it good if I'll consider missed one thing? I mean, just what I'm thinking, simple my approach. I'm thinking like it's just whatever the numbers that are negative, we need to shift into the positive side so that we can prepare a bigger list. And maybe for the 0 onwards numbers, positive number, we have to shift them to double of the numbers that are there. Will it be good approach? It's like you are taking double memory because the space can be between negative to positive numbers. Okay, let's do it. I mean, let's use it, the approach that we just used. So let's imagine our target can be, okay, sum of number positive. If I'm taking all the positive sum of nums will be plus k, and negative, I mean, if I'm taking all negative, first case scenario, then will be minus k. Okay, it is a possible option. So total, if you say minus k to 0 to k plus 1, so this is a space where the numbers can lie. So what we can say, 0 to 2k plus 2k, I mean what he added, 2k, so 2k, 0 to 2k, and whenever whatever target we are getting, so then also the challenge is for 0. Will be 0 to k minus 1, and k will be representing 0, and k plus 1 to k, what I did, to 2k, this means 1 plus 2 plus 3 plus k. So these are k numbers, these are k numbers, and this is 0 representing 0. So when I'm storing the numbers, what I'll say, whatever the target value I have right now, little math, oh god, I'm just forgot the time, and 11 minutes I have. Okay, So if I'll do target percentage by okay, we'll take absolute of target. Okay, whatever the value that we are getting positive, so it will be whatever the value that we are getting positive. I mean, if it is less than by 2k, if I'll do what we'll get. If it is 0, no, we'll get target a result target between k to minus plus k, and now we need to map it into 0 to k. So why don't we say something like, if it is value is k, so k minus k will be 0, and if it is positive then k plus k will be 2k. Thinking simple expression. Let's see, I just got something. I mean, yeah, simple approach. What can we do? So let's calculate first. S is nothing but sum of nums. Nums will be positive, so let's call it k. K is this one. Then the total range of elements will be 2 into k is 2k plus 1, so 0 to 2k. Great. Target, whatever target value that we are getting, we'll say okay. So target is about something like we have k, so why don't I pass k? I don't know if I'm using this right approach or not. Let's explore it, man, no problem. So I got k, then you will say, whenever you are checking, you will say k plus target and k plus target. It looks weird, yeah. I don't know. And literally logically, what should it be? Something I'm doing, I don't know if you can optimize the memory, and if that would be the case, then I'm thinking from very dumb point of view. I don't think it will work. Somehow I feel like somewhere I'm making mistake. Where is k? Yeah, here we need to pass k. Oh wow, it's working. Let's see if it is. If it is working, I thought I'm printing something, right? So I'm assuming this is the case. Problem causing. Let's see. 45. Club isn't the best place. Failed. So bad. God. Still failing. Let's see what is the wrong option. List index out of range. Okay. I took 2k plus 1. Bro, 5 minutes only left in our last 45 minutes. God. Panic mode on. Okay, where have I made mistake? List our index out of range. And k plus target. Target will be negative. So negative. What is the target value that can go up to? Can go up to k. Sums of like you are keeping all the numbers positive, positive, positive. Or it can go minus k. So if you are taking target, adding k minus target minus k, it will be 0. If we will take plus k, where is the problem, bro? Fuck. Mem of I k plus target. Where is the fucking 2 into k? K is sum of nums. Nums will be always positive, I believe. Okay. Think more. Mistakes. So many mistakes. Okay. -1 for underscore in range 2k plus 1. No, not. You are not thinking. So, okay, nums, sum of nums. I'm taking sum of all the nums. I took all the nums will be nums of I can be 1 to 10 power 4, so it could be positive number 10 to the power 4, it could be negative 10 to the power 4. So what you did, simply you took -1, 2 into k plus 1. I will take this and plus 1, 0 to 2k. How will I get it? I k plus 1 target equals to result. Print I k. Shall I print it? Will it work? Three 16, 2 16, 0 16. Uh, what is the input? What is the input, bro? Uh, K becomes. What the heck? Let me take 15 more minutes. I'm a loser, I'm really. I don't want to use harsh word to me. I still feel. I made mistake, bro. K equals to 16. No more false. Deck. They are testing with different ones. Not what they mentioned. Okay, no problem. If k equals to 1, there is one element. Sum of that is 1. So k can go to -1 to +1. So total 2. Mem, what will be mem? Oh god. plus nums of I. I got it, something. I got it. Target. I forgot one the corner case I will. Target is bigger number. Where I kept target? What a minute? I did one mistake. Still runtime error, fuck. I thought it's because of it. What is the heck? Yeah, I'm missing something. Let me print. Print I k plus target. Just want to see where my brain is not working and it is taking something big, stupid thing. Print I and k plus target. Oh god, I man. Fuck off. It's not getting. I don't want to debug any other options. What it will do if k is 1? Let's think. We'll start with I equals to 0. So first element, we'll say okay I equals to should come here. I equals to 0. Where exactly the problem is? Okay. 1 hour I just wasted. Fuck off. I don't know what it will be. Stop it, bro. Just shut your mouth. Shoot. It's a daily habit. Cake R1. I mean, I'm not able to debug it. जो आउटपुट भी नहीं आ रहा. K111002. Think, bro. Where you made mistake? Let me do one thing. Result equals to there is something that will be. I'm not able to get it. Oh, again this. They are deriving it. Okay, so no, bro, I need to solve it. Either watching solution. First, I need to check what's wrong with my problem. Solution. Don't want to use ChatGPT. Fuck. Let's see the solution first. Let's follow the same. Let me see this recursion first.
And the problem is target sum. So let's understand the problem first, and then we will see how can we solve this problem. 3, 1. Assign signs either positive or negative to the array elements. For an example, if I assign positive to 1, positive to 2, negative to 3, negative to 1, and if I sum it up, so plus 1 plus 2 is 3, minus 3 is 0, minus 1 is minus 1. So you get minus 1. Similarly, if I assign something as, assume minus plus plus minus, then minus 1 plus 2 is 1, 1 plus 3 is 4, 4 minus 1 is 3. So you get 3. So you have to assign signs either positive or negative. And by assigning signs, you have to tell us how many ways can you assign signs such that you get the given target. For an example, over here, if I assign this as 1, like 1, 2, 3, 1, if I assign minus, plus, plus, minus, this is the first way in which I can assign signs such that I get the summation as 3. Or the other way is I can say, what if I assign, like, let's remove this once. What if I assign something as plus, minus, plus, plus. So 3 plus 4 plus 5 minus 2, 3. So there are two ways. Yes, there are two ways. One is plus, minus, plus, plus, while the other one is minus, plus, plus. So if you assign signs in these couple of ways, one is this, the other is this, you will end up getting the sum of 3. So that is what they're asking you. In how many ways can you assign? So there are two ways. So the question is pretty much clear to you, right? Now, if this question comes up, obviously straightforward, since you have been doing DP on subsequences, your brain will start saying, so let's apply recursion, let's write f of index, target, and there will be a couple of possibilities, either assigning, like everyone would be like, either assign positive, either assign negative, and keep on doing the recursion. That is correct. That is correct. But can we do in something better? Because yeah, you can definitely write a recursion which is like you take a couple of ways basically saying something like this, where you say f of index, f of target, and there'll be a couple of ways where you assign the plus sign, the negative sign. As the question says, count the number of ways, you return plus, plus, negative. That is the common recurrence that you can do. But can we solve this using any of the problems that we have solved previously? Because if we can solve, like, what have we learned till now? We have learned problems like subset sum. We have also done a problem which says count a partition subsets into two such that you have to count how many have S1 minus S2 is equal to T. So you can see that this is the problem that I was talking about, count partitions with a given difference, S1 minus S2 equal to 2. So you must have done these couple of problems in order to solve this particular problem. Now let's see. So what was I given? I was given 1, 2, 3, and 1. Okay. So can I say, what am I doing specifically? If I'm assigning minus over here, I'm assigning minus, I'm assigning positive, positive. I'm basically doing 3 plus 2, minus 1, and that gives me 3, right? So can I say I am assigning some portion to a subset S1, which is 3 and 2. And then if I take a negative common, I'm assigning 1 and 1, right? Therefore, this summation is 5, this summation is 2, which gives you 3. Is this question done? Yes, this is done. We have already done a problem where we say that given an array, divide them into two subsets such that this subset, like the first partition has subset sum S1, the second partition has subset sum S2. And if you subtract T, you have to count these many guys, you have to count these many guys. We have already done this problem. And if I say this problem is pretty much similar to that, I won't be wrong, because this is one of the ways. Now, if I just erase this, and I say I'll apply the signs in the opposite fashion, minus, plus, plus, minus, then 3, 1, 1 go to one subset, and the other subset will just have 2. So this is basically 5, this is basically 2, again gives you 3. So the question is exactly the similar. They've just changed the language. Yes, they've just changed the language. The question is very much similar. Divide them into two partitions, divide them into two subsets, such that S1 is the subset, S1 is the sum of the subset 1, S2 is the sum of the subset 2. And the difference is the target that you're looking for, because that is what you have been doing. This is the target, right? This is the negative elements. You can say these are the positive elements. You can say, or can be vice versa as well. So we have actually boiled down the problem into dividing them into two subsets, such that the difference between those subsets are target, because I know one of the subset will have all the positive elements or the negative, and the other subset will always have all the negative.
Why I'm not thinking like that approach? Okay. S is nothing but sum of nums and S1. Okay, so target will be nothing but okay. TS target sum I'm just ask is nothing but, so here let me solve it. So TS is nothing but S1 D target plus S if target plus s percent is by 2 equals to 0, return not equals to 0, return 0 because not possible. Target sum. Okay. Mem will be nothing but for underscore for underscore in range 1 to n, not 1 to n. Okay, return self solve I n target that I'm looking for ts nums and then define solve self dot I index n and ts target sum nums memory. If I equals to 0 n minus 1, that means you reached the last element. Why do we need that? I greater than equals to n, return. That means no, I need to check one more. This is impossible. If I greater than equals to n, return 0. That means not possible. Ts equals to 0. Possible. Finally, target sum equals to 0. Can it be target sum at starting only 0? Maybe you are looking for minus. Target is nothing but equal to sum of the elements, then it will become 0 and there will be only one possible option. Yeah, so that's correct, it will work for that. And if mem of I and ts greater than equals to 0, return mem of I and ts, else what are the options? You have two options, either consider this element or not consider. If you consider, then take will be if ts if nums of I less than equals to target sum, then take, and you will say take equals to 0, and if nums of I greater than equals to ts target sum, so Well, okay, you will consider it. And take will be nothing but self target sum, and then you will say okay, no problem. What will say? I will jump into another one, I plus 1, and ts minus nums of I, and what else? God, nums memory, and not take. You are not taking this nums memory, and return result equals to take plus not take, return okay, mem of I and ts equals to result. Where I kept zero. Ah, my Mansik condition is not good, I believe. It's just I'm desperate to solve it. Wow. Missed one case, I definitely know. It is saying there was a bug. 1-0, and my target is 1. Plus 1, plus 0, minus 1. No, plus 1, minus 0. And what I missed now, if I'll say 1 minus 0. I think I made the same mistake in the past and I'm making the same mistake again. जो क्या ये लिख this is a condition like if you are getting 0 at the end. Oh, okay. I'm missing some part still. modulus. So I just wanted to write one thing. Once you make mistake, you are busy. Else you are MC. So many mistakes finally accepted. Today I'm just killing everything badly. How much time I took, man? 1 hour 35 minutes, Banchot. Oh, sorry. I'm so sorry. I was not expecting this in this call. I need to solve the another way as well. It is the same problem, but let me copy few things from here. Here we don't need to use the conditions that I used. So we got this. Here we need to use table of let's formalize it first. So it will be 0 up to ts, 0 up to n minus 1. These are the elements. If there is if there are 0 elements and you are looking for 0, then that is one possible option, right? If you have 0 elements, you are looking for something else, then that means it will be 0. And now here comes the part if you have one element, okay, and you are looking for 0, one element and you are looking for 0, then better is it's like we don't need to calculate it. It will be like you can take it or you cannot take it, so 2 options. So that's why comes 2 things. And for all other steps, take, not take. If you are taking, take will be j. If array of I less than equals to j, then take initially will be 0, take will be what if you are considering it, then well of what you have to look for the previous one. So table I minus 1 and j. If you're taking on you considered this element, so now you have, so imagine this is the state of array, so you'll ask for previous what is the count, whether you are able to make, and accordingly it will decide. So it will say J minus, I'm considering it's current of I. Okay, not take will be, I'm not considering, so table of, I mean this element won't be considered, and Z will say okay, not considering, so this one. And that's where like you will get to. Okay, I was doing something. I mean, today I don't know when I will start AI part. I will cover at least 1 hour. That's for sure. So maybe 3 to 4. Today I have to grind little more. I mean, I don't know. Whenever I'm thinking, like today I have to finish things quickly. I don't know what God wants from me. Always happens like my memory starts hanging. Okay, but I'm not learning from the mistakes. That's the biggest mistake I'm doing. So, what we say? Initially, actually, we don't have to consider complete table. So, what do we need to take? Previous will be like what we say, for underscore in a range uh, ts plus 1, and let's stay so do 0 for each, and previous of 0 equals to 1. And what I'll do, I will copy its placeholder. It's not going to, let's do 0. I will keeping everything 0. Base case placeholder, God help me, no, for I in a range 1 to, oh bro, 1 to n plus 1, no, n, yeah, n minus 1 we are looking for. C. Okay, one thing I made mistake. Actually here you are representing like you are taking how many numbers of elements. If you are taking 0 elements from it, so that's its conditions. Okay, for C in range I took one more space. I don't need it to manage, but still I'm doing it. Okay, so the thing is like J will be TS plus 1. Alright, now so what take will be, that means okay, take will be 0, and if current, if nums of I is less than Z, you can take it less than or equals to Z. Both are acceptable. That means this element can be taken, and so you will say take equals to previous of what? You will say I minus 1. You don't need to say that. Just say Z minus nums of I. Okay, this is one thing. Else if no, bro, I'm thinking something else. Whatever. Not take equals to previous of J. God. Previous of J. That means you are not taking this one previous row, and the amount will be like the target will be same. So previous J, and then we'll say current value of Z is nothing but take plus not take, and return current of Z. So many things are in the, I don't know, previous equals to current. I believe I made some mistake, definitely. Return, not return. Okay, I haven't done this. Wow, Betty. Good progress. Fuck off. I have to divide with Modi. Modi and Melody. So sorry. I'm not making. Just trying to be funny. But so many submissions. See, 2, 3. God knows what I'm making mistake. They will never forgive me. That's all for this video. Yeah, okay, finally has so said. I'm not sewing, whatever. Okay, that's all in this video. And I mean, thanks.